So here's a question that keeps coming up in ML infrastructure. What if you need to embed billions of documents, but transformers are too slow, and FastText only gives you a classification score? Today I want to walk you through a paper called Luxical from DatologyAI, and I also want to compare it with FastEmbed, which is Qdrant's popular embedding library. These are three very different approaches to the same problem. How do you get embeddings fast enough for web-scale data pipelines? Let me set the stage. When you're building LLM training pipelines, you need to organize trillions of tokens from web crawls. Most of the data is garbage, it's redundant, off-topic, or harmful. You need to filter, cluster, and deduplicate at massive scale. Now, your options used to be pretty limited. You could use heavy transformer encoders like BERT, great quality, but maybe 70 documents per second on a GPU. Or you could use lexical classifiers like FastText, super fast, but you only get a scalar score, no vectors for clustering or retrieval. This is the gap that both Luxical and FastEmbed are trying to fill, but they take fundamentally different approaches. Let me break down three approaches and what makes each one tick. First, FastText. This is Facebook's lexical classifier from 2017. It used bag of n-grams with a shallow neural network. Extremely fast. We're talking about thousands of documents per second on CPU. But the output is just a classification score. You can't do clustering. You can't do nearest neighbor search. It is a one-trick pony. Second, FastEmbed. This is Qdrant's library. It takes existing transformer models like BGE or mini-LM and runs them through ONNX Runtime with quantization. So you're still running a real transformer, just optimized. The output is a dense vector, which is great for retrieval. They claim 2 times to 3 times speed up over the linear PyTorch inference. Third, Luxical. This is the new kid on the block. It's a hybrid approach. You take a sparse TF-IDF vector over 5 grams, then pass it through a small ReLU network to produce a dense embedding. The key insight is that the input is sparse. Only a few thousand n-grams appear in any document. So the metric multiplication becomes a simple gather and sum operation. So, how do they actually stack up? Let me walk through the key dimensions. Throughputs. Luxical reports about 6,800 documents per second on a M4 Max CPU. FastText with DCLM scorer gets around 5,600. FastEmbed don't publish exact numbers, but they claim 2 times to 3 times over sentence transformer, which puts them roughly in the hundreds to low thousands range, depends on the model. Output flexibility. FastText give you a scalar, FastEmbed and Luxical both give you dense vectors. So for clustering, deduplication, and retrieval, FastText is out of the running. Model architecture. This is where it gets interesting. FastEmbed is essentially a delivery mechanism for existing transformer models. It doesn't change the model, it optimizes the runtime. Luxical, on the other hand, is a completely different architecture. It learns to distill the similarity score of a transformer teacher into a sparse to dense projection. Quality. On Luxical's document have matching text. Luxical 1 trails behind a large transformer at the strict top 1 retrieval, but at coarse grain retrieval, that is top 1% or top 10%, it catches up significantly. My take is that each tool occupies a different niche, and the right choice depends on your constraints. Use FastEmbed when you need high-quality embedding for RAG pipelines, search, or production application where latency matters, but you're not at billion document scale. It's easy to integrate, it's well maintained, and you get access to a wide range of models, including multilingual ones. Use Luxical when you're doing web-scale data curation, sync semantic deduplication, clustering, or quality filter across billions of documents. The throughput advantage really shines when you're embedding once and reuse the vectors for multiple downstream tasks. Use FastEmbed when you just need classification score and nothing else. It's still the simplest tool for that job. That said, I would note that Luxical is only evaluated on English web documents, so we don't yet know how well it's generalized to other languages or domains. FastEmbed, by contrast, already supports multilingual model out of the box. So, to wrap up, the embedding speed quality frontier now has more options than ever. FastEmbed optimizes the runtime of existing transformers. Luxical optimizes the architecture itself by going back to sparse lexical features with a learned projection. If you're processing billions of documents and you need dense vectors, not just classification scores, Luxical looks like a compelling option. It's not going to replace your BERT encoder for high precision search, but for coarse-grained organization at web scale, that could be a real game changer. Both Luxical and FastEmbed are open source. Links in the description. Go check them out. See you next time.